Today two editors open the same work item at version 1. The first changes the title and receives version 2. The second submits an older copy with version 1. Instead of silently replacing the first person's work, the API returns for 09 conflict with one safe instruction: reload the work item and try again. A final read proves that the winning title is still in the database. This slice crosses the model, EF core mapping, migration, store, authenticated endpoint, HTTP contract, and relational integration tests, while another user's item still looks like not found. The mental model has 3 steps. Read the resource and its version. Send both the intended change and the version that was read. Then let the database update only when its current version still matches that original value. EF core includes a configured concurrency token in the update predicate. If another request already changed the row, the predicate matches 0 rows and EF throws DB update concurrency exception. That exception is useful information, not a 500 error. It tells the application to choose a conflict policy, reject, retry, merge, or ask the user. This lesson deliberately rejects and reloads. The work item gains an integer version. New items start at 1, and every accepted rename advances it inside the domain method. The checked addition prevents a theoretical overflow from wrapping silently. In the EF model, version is required and marked as a concurrency token. The generated migration adds the column and backfills existing rows with 1, so old records have a usable token immediately. This application-managed token works with the project's SQLite setup and keeps the mechanism visible to beginners. On SQL Server, a database-generated row version is another strong option, but provider-specific behavior deserves provider-specific tests. A concurrency token only helps when it crosses the disconnected HTTP boundary. Create and list responses now include version. The authenticated client sends the new title and the version it originally read to put API/workitem/ID/title. The request still contains no owner identifier. Ownership comes from the server-issued name identifier claim, exactly as before. A missing or non-positive version is invalid input and receives 400. The token is not a secret and it is not an authorization check. It is evidence about the state the editor saw. Authentication and owner scoping remain separate controls. The store first loads the row with both its identifier and the authenticated owner identifier. If no owned row exists, it returns not found without revealing whether somebody else owns that identifier. The loaded entity contains the database's current version, but EF needs the caller's expected version as the original value. We set that explicitly, then call rename, which changes the title and advances the current version. Save changes produces one update whose where clause contains both the primary key and the expected version. The comparison and write happen together in the database, leaving no gap for another request to slip through. When the expected version is stale, save changes affects 0 rows and EF core throws DB update concurrency exception. The store catches that specific exception, detaches the rejected entity, and returns a small conflict result. It does not expose generated SQL, database names, exception text, or the tracked stale values. Detaching is a useful habit when a DB context might continue doing work after a failed save, because the rejected changes should not be written accidentally by a later call. This endpoint uses one scoped context, but making the store result explicit keeps persistence mechanics out of the HTTP layer and makes the intended conflict policy easy to review. The endpoint preserves 3 different outcomes. 400 means the title or version is invalid and the caller must fix the request. For 04 means no work item owned by this identity is visible. The same response protects both missing and somebody else's identifiers. For 09 means the request was valid for an older state, so repeating it blindly is unsafe. The response uses authored problem details that tell the client to reload without revealing the winning title or any database detail. A richer user interface can later show both versions and offer a merge, but the server must first make silent data loss impossible. The relational integration test creates one authenticated user's work item, captures version 1, and sends 2 updates with that same original version. The first returns OK with version 2. The stale request returns conflict and contains the safe reload instruction. The test then calls the real list endpoint and asserts that the first editor's title and version 2 remain stored. Separate tests prove a successful rename, reject invalid input, and return not found when another authenticated user targets the identifier. The complete release suite now has 26 passing tests, 0 failures, 0 warnings, a clean migration model, and no vulnerable packages. The tempting shortcut is to load the RAW, compare its version with the request in C#, and then save without configuring a concurrency token. Another request can commit after the comparison but before your update, so the later save still overwrites it. The protection must reach the database update predicate. Also avoid catching every DB update exception as a conflict, constraint failures and infrastructure errors need different handling. Finally, an automatic retry is not automatically safe. Retrying the stale title against the newest version may recreate the lost update. Reload, merge deliberately, or ask the user whenever business intent cannot be combined mechanically. We added one portable version token, mapped it as an EF core concurrency token, migrated existing rows to version 1, returned it through the API, and required it on title updates. The store places the expected version in F's original value so one SQL statement performs the comparison and update. Stale writes become an explicit conflict result and a safe for 09 response. Owner isolation, validation, and the winning database value are all covered by real HTTP tests. In Episode 7, the companion application starts a new feature arc with its first working signal archet slice, while these persistence and security boundaries stay in place.